Car moving in a circular path. The car traveling on a circular track varying the angular acceleration every time is an example of non-uniform circular motion. The speed of the car changes as it is accelerated. The centripetal and the equivalent centrifugal force acting on the car to keep it moving in a circular path are also responsible for the variation in the speed of a car. Windmill. The speed of the windmill as the wind strikes the propellers is small initially, which is then intensified by the shaft and motor attached to the propellers. This helps the windmill to rotate for a long duration and converts the wind energy into electrical energy. Athletic running on the circular track. Consider an athletic running on a circular track. The speed at which the athlete had started running was moderate than the speed he opted to cover a final distance. In the middle, his running speed was slower. He has continuously varied his speed while running on a circular track signifies the non-uniform circular motion. Tires of a bicycle. The speed of the bicycle depends upon the angular acceleration of the tires. A bicycler has to constantly paddle to increase the speed of the bicycle or to maintain the speed at constant velocity. In a journey, the bicycler will reduce the speed, keep it constant, increase, or apply brakes, thus the acceleration of the tires keeps on varying, hence it is an example of non-uniform circular motion. Gravitron. Gravitron is a cylindrical shape spinner you will find in the amusement parks. The person is made to stand attaching the back to the wall of the gravitron. The speed of the gravitron keeps on increasing once started accelerating and then decreases gradually when turned off. Due to the centrifugal force acting outwards from the center of the gravitron, people tend to remain attached to the wall of the gravitron without any support. Fan. The speed of the fan is regulated by the regulator of the fan. On turning the fan on, the fan starts rotating due to the charge stored by the capacitor. On turning it off, the fan continues to rotate because of the charge stored within the capacitor. Just by putting on the fan and turning off the fan, you will see the non-uniform motion of the fan. Ball rolling from the slider to a ground. The speed of the rolling ball increases till it hit the plane surface at the end, and then the angular acceleration of the ball decreases. The variation in the angular acceleration of the ball sliding from the steeper to plane surface is a non-uniform circular motion. Merry-go-round. The speed of the merry-go-round increases and then decreases gradually at the start and while stopping the round. It consists of chairs suspended from the center of the mechanical structure through a rope or rod. The centripetal force acting on the body helps to keep the body in place by cancelling the centrifugal force outward. There is a change in the angular acceleration of the merry-go-round and hence it is a non-uniform circular motion. Pulley. A pulley used to draw the water from the well changes the direction of the force and makes it easy by reducing the amount of muscular force required to pull the volume of water upward. The angular acceleration of the pulley varies depending upon the rate of pulling the rope. It increases and decreases regularly. Grinder. The circular motion of the grinder is due to the friction caused between the moving rotors and the container. When we turn off the power to the grinder, the acceleration of the grinder is conserved and it continues to accelerate with decreasing angular velocity, resulting non-uniform circular motion of the grinder. Mixer. The particles of a mixture in a container will move in a circular motion along with the accelerating blades in a rotational motion. When the mixture is turned off, the mixture continues to accelerate as the momentum of the particles is conserved for a while, decreasing the speed in a circular motion. Swirl in water. On stirring the water, the particles of the water will move in a circular motion. The speed of the particles will decrease by removing the stirrer from the solution. Cyclone. The speed of the cyclones depends upon the energy acquired by the particle comprising a cyclonic system. The speed of the cyclone increases if the pressure of the system is low and decreases if the pressure rises. Ball in projectile motion. A ball spinning in a projectile motion will decrease its angular acceleration when it reaches the highest point in the flight and increases while rising and approaching downward towards the ground. Spinning top. The acceleration of the spinning top depends upon the conservation of the angular momentum and the center of the moment of inertia. As the point of inertia varies, its momentum changes, and the speed of angular acceleration decreases. Marbles. The speed and the angular acceleration of the spinning marble change by hitting it with another marble in a path. The collision is inelastic and the momentum acquired by the marble depends upon the velocity of the marble it is colliding with. Shopping trolley. The circular motion of the tires of the trolley depends upon the push force applied on the trolley. It will move on putting a force with respect to the walking speed of the carrier. Sand particles swirl in the water. The sand particles mixed in water will move in a circular motion on swirling. Based on the increasing or decreasing the rate of swirling motion of the handed velocity of the sand particle in the water will increase or decrease respectively. Concrete mixer. If you have noticed the motion of the concrete mixer, you will see that the velocity of the mixer on starting the machine will increase gradually to the highest speed, and on removing the power supply, the speed of the mixer decreases gradually. Spinning the ball on tip of a finger. This is a small game to locate the center of gravity of the ball and place it on the tip of a finger and spin the ball for a long duration. The angular acceleration of the ball decreases. Frequently asked questions. Is the hula hoop an example of non-uniform circular motion? It is a round circular hoop twirled around the body. The speed of the hoop depends upon the force applied to it while twirling and the number of twirls you gives. What is varying in non-uniform circular motion? The speed of the object is varying to produce the non-uniform circular motion. The tangential velocity of the object is a circular motion that continuously changes, resulting in a non-uniform circular motion. Please visit our website lambdageeks.com for more articles on technology, engineering, mathematics, and various other domains. Scientific calculator and many more other tools.